So we've already looked at how we can identify the different types of decay. We're going to focus in a little bit more on the physics principles required to actually answer these types of questions. So this is one we've seen already, the alpha decay of uranium-238. So I have uranium-238 with 238 nucleons. Uranium has 92 protons. This undergoes an alpha decay. So I'm producing an alpha particle. Now the physics principle that we need to use to answer this is physics principle 8, the conservation of nucleons. If you look on your periodic table, your physics principles sheet, conservation of nucleons is physics principle number 8. That requires the total number of nucleons to be the same before and after the decay. So I need 234 nucleons on my daughter nucleus in order for the conservation of nucleons to work. When I talk about protons now, we want to think about physics principle number 7, the conservation of charge. My total charge at the start, I have 92 protons. And I'm not showing you any electrons because that's not really important for these decay events. So I still need a total of 92 protons at the end. That's how I know I have 90 protons remaining. And so that must be thorium. So when I'm talking about changes in the amount of protons, or I'm looking at the amount of protons, I'm looking at charged particles. So that's conservation of charge. And it becomes even more important when we're looking at beta negative or beta positive decays. Because we need to use that physics principle number 7 in order to identify which one of those is actually occurring, because I can have a neutron giving rise to a positive proton and a negative beta particle. Or in beta positive decay, I can have a proton giving rise to a neutron. So these are things that I can see. This is an example of what's called the Decay Series. So there's thorium-232 at the start, and it shows all the decays that happen as it reaches the stable lead-208. Now we can write a decay series out in a different way that doesn't show any of the decays that happen. So it gives rise to radon-228 with 88 protons. This gives rise to this one with 228 and 89 protons. And then the thorium-228 with 90 protons. So let's just look at those first 4 elements and those first 3 decays that occur. And using our physics principles, let's determine what type of decays are actually occurring. Well, in this first decay, thorium-232, decaying to radon-228, well, I can use my conservation of nucleons to determine how many nucleons I'm short. And in this situation, I see that I'm short 4 total nucleons. And then looking at the difference in protons, I'm short 2 protons. Now, I can recognize that right away, and I know that's an alpha particle, a helium nucleus, or I could draw it the other way. But this is an example of an alpha decay. And I determine that using the conservation of nucleons. In the next example now, I have radon, which undergoes another decay. And in this situation, at the end, I still have 228 nucleons. However, I have 89 protons now. So this can't be an alpha decay because I have no change in my mass number. So what form of beta decay is this? Well, I can use conservation of charge to determine this. Before, I have 88 protons. At the end, I have 89. So in order for my charge to be conserved, I need an extra -1. So this has to be beta negative decay. And if that's the case, then I also need to remember to include an antineutrino. Because of conservation energy and conservation momentum. Again, these negative beta particles aren't moving as fast as we would expect because they're very light. Now we have one more decay left. What type of decay is this? In this situation, I have 89 protons to start with, and then at the end, I have thorium-228. I have 90 protons. So again, using conservation of nucleons, that value doesn't change. However, I need a -1 in order to conserve charge. So this needs to be beta negative decay as well. And so I need to include that antineutrino. And we could go all the way down that decay series. So we can use physics principles 7 and 8 to determine what type of decay has occurred and what type of particles have been emitted in that decay event.